Good morning, everyone, and welcome back to Project CD Chronicles. With today's video, I wanted to show the continuation in the beta phase of a project I had brought to the ANSI channel. It's about the high-level assemble. As for the Commodore 64, it was an alpha version, essentially still functional, and in which, as always, regarding my GitHub site, I have brought an extension. Now, the beta part, although rudimentary, I have expanded it to the remaining Commodore 64 machines and made some small improvements. Obviously, the project is ongoing and I would like to present it to you. Who knows, maybe in the future I could extend the project, perhaps even to external collaborators or those who are interested. So we need to go to the GitHub page, my personal one. Obviously, this is a bit misleading because I had done an alpha phase of what is a high-level assemble. Regarding the machines, it's essentially only about the Commodore, and the first part was relatively solely and exclusively about the Commodore. For what is it? We will see it right away. And now I am moving towards what is a beta part. Clearly it's misleading because obviously the alpha part works significantly more than the beta part because the beta part only has what is a code transcription. What have I done in these two parts? Obviously the part from alpha to beta has been optimized for various routines, have been added, and also, let's say, some peculiarities. Clearly, I have it on my local GitHub, and soon I will put a counterpart on the public GitHub. A brief digression. Where does this project originate from? We need to go to Webster University, where at the time with the 6502, I was following what Randall High, the professor, was doing, so to speak. And I had already talked about it in a video on the channel, which I'll leave the link to, about what was a high-level assembly regarding the 32-bit, which could be done with NASM and then could be ported, if I'm not mistaken. They were also on Linux, TASM, FASM, and other machines. And it was an assembler that you could interact with at a more advanced level of abstraction. From here, the idea is born. And we need to go back to what is our HLA in the alpha, a phase. Clearly, there is a very tight little here where I had conceived, let's say, the same phase in which it was possible, so to speak, using what was an assembler but a little higher than the assembler. And then here we have a sample program, but essentially it was a little lower than what the language provides. See, so it was halfway, and I had essentially implemented what some called a bridge, some bytes. Exactly. There were also the addresses. Obviously, arrays are there because we know that in C, arrays do not exist, but they are pre-calculated. So essentially, it was already possible to do this. But now we have reached what is the second part, the beta, and I will briefly illustrate it to you. Let's return to what is the beta part. Obviously, you see here it is more sparse. Moreover, in the second part of the video, there will be always regarding, come on, the channel, the future prospects. And according to the surveys, well, and what I have seen, let's say we will do what is on a roadmap. What happens here? Basically, I have added a few things actually, because I just need to do a porting from what is from the alpha to the beta and try to optimize and reduce a few bugs. What I have added, first of all, is a preprocessor that we need to compact the console code. And the novelty is that I have brought in what are the routines, because not all of them are here yet. At this point, I have called it not nlib64, just for the COM64, but I called it muslib because all the routines, but we will see them working locally, and here it's just a counterpart. Let's go see it locally. For the Commodore 64, the VIC-20, all the expansions of the VIC-20, which also here, each expansion changes The screen changes the locations, and there is also a counterpart for the Commodore 128 that I made practically last night. Obviously then, as far as the graphics for the Commodore 64 and VIC-20 are concerned, the routines will still be different. However, we will see it in action right away. The peculiarity is that everything is parameterized, and thus, with the same machine language code of the 64 tax, it is possible to port the code to both in machines with minimal effort. But let's see it in execution. As you can see here, we are still in the alpha version and even corrected what could have been a rather insidious bug. Thanks also to Stack Overflow, where there is a particular condition in which it was possible that a double freeze or an incorrect deallocation of a pointer could occur. These are those insidious cases in CI where one must be extremely careful. Essentially, in the alpha phase, this is the pseudo language we had constructed, which is still similar to CI. It recognizes pointers and can perform what is automatic casting, uses various castings, allows the introduction of what is an entire counterpart name directly in Marketer language. Here you see I had done what was a cast. It clearly resolves what are the pointers and the various addresses according to the type of pointer, and then through what is the compilation. Here are the various compilation phases. It goes on to produce what is essentially an assembler file. But I made it in a way that is human readable. You see here it already allocates what is the structure of the local stack, and these names, despite being on the local stack, can already be accessed directly with a simple X, so it loads the DPV address in the local stack. Well, it does other things, but this is then the machine language. It's the assembler. It's not yet clearly optimized. And here, well, since it's a debug phase, it also lists where it is with the lines and so on. But this wasn't what I wanted to do. We arrive at the beta version, and I remind you that in the second part of this video, there will be the future of the channel, and we will see a bit how to move forward. Essentially, we launch it, but we don't care about launching the program itself. It's clear that here it tells us nothing, but if we have the location 4960, and it contains certain numbers 1, 2, 3, 4, and so on, we will see that this is a pointer where it contains the location, and through differentiation, then it goes to take 1, 2, 3, 4. It's clear here it says everything and says nothing, but more or less that was the focus of the HLA level assembler presentation. Now, let's see the beta versions, which is what I'm doing now. I've made some improvements, so enhancements, but now let's come to the new beta version. You see essentially here there have been improvements. We have first of all a general inclusion library, and then look at how many specific libraries it goes to drive all the machines in a particular way. If you can see the VI C20, it goes to drive all the series of extensions, and among other things, once we have introduced what is the main header and the specific header, all the other libraries refer to it. Those that are default parameters. And therefore nothing needs to be changed. So, in fact, the code is very simple to carry over. And first of all, let's briefly examine this part here. Very briefly, how that new concept of a library is structured. Previously, it was made solely and exclusively for the 64 target. Now, as you can see, there are numerous targets, and among others, we have the VH20, which, as you know, and I have recently learned, regardless of how the memory is handled, and it extends the screen locations, also change the initial line part of the program address and so on. I have also brought what is a 255 byte stack library. At the moment, there is a long size that I still need to make 1024, but it can also be 4096 depending on the needs. Clearly, this is very fast and can still be indexed with the comma X, whereas here a calculation of the locations is really needed. Moreover, being parameterized, we go here to see, we have all the various references of the machines for each machine. And therefore we have the starting part, the top bottom memories. What is the extra mem from C0 to C? And so practically we could also bring the stack into the various other parts of what is the memory. So essentially, if we don't do anything extreme, we can also bring them directly into what is from page 0. Obviously here it is very limited for this part here. And as you can see also here in the part of the WIG20. And this is regarding a 32-bit expansion that we will see later on. It is capable of using it and managing it correctly with parameters that will not essentially change. This is the main library, obviously. You see here is the library regarding the COM364, but the VIC-20 and the rest does not change because we will only make a reference regarding the library, the target, the screen width, size, height, build map, and we are not interested obviously in where the original locations of the machine are, but we are essentially interested in using these because once we have included the header, then the machine will handle it in a parameterized way, directly writing the correct locations. And indeed, if we want to see the base ROM of the COM64 starts at A0, while the base ROM of the TXE20 starts at what is C0. In short, there are some differences. Then it also starts with what is the COM16 and +4. However, in terms of architecture, they are actually quite different. What I wanted to show you is this, which is a substantial example. And you see that it is really very, very easy in this part for the simple reason that we close what is the general header library, which includes a whole reference of locations as well on page 0. Simply with the program, the line is made, it calculates everything. And then we include what are the libraries and what is the strength of this. It's that this line of code, as you can see from the COM64 to the V20, essentially remains completely unchanged. So even the porting of the various locations, here you also see the 3K and so on, remains essentially unchanged. Now let's do some test compilations and we will see what is running. As you can see, this is the compilation line regarding the Commodore 64. It aims to print a character here and here on the screen. Here it is correctly compiled, and we briefly run it from the Commodore 64, and you see the target is still 0, and it prints correctly. The numbers in the locations will also be able to do it on the VIC20 in the extensions on the Commodore 128. But let's take a look right away. As you can see here, essentially the program is unchanged. You see here, nothing changes for you. We compiled it with this command line. We also have our X here. At this point, we choose the V20. And you see correctly, it brings the locations. And this is clearly the value 1 correctly on the screen and other things with the same line of code that you can clearly see here. It is unchanged. Well, obviously, I've already set this up. We have a 32K extension. So here, it also uses what is the memory, which I have called extra memory, that goes after what is the character ROM. We run it, because we have already compiled it, as you can see here. And we run it directly on our Vice machine. Here too, as you can see, it prints correctly. The screen management, there is no problem. And what is the one is printed in, what is the app for memory, if we want to call it that, and so on. And obviously here too, you see GSR, stand print, unsigned, whole, and decimal, which is the same for all the others. And obviously, machines. Last but not least, we also have the management of what is the Commodore 20. Clearly, the program does not change. There's no trick, no deception, the usual. We have defined this part here. We launch it. And also here G, because anyway, the target is number 7. What can I say for now? That's all. There will be extensions later anyway. Invoices. Still a little information about the HLA, about what it is. And then we move on to the second part of the video. Last bit of information. Obviously, everything is already set up to do the port from the alpha core to the beta code. Everything is essentially already set up regarding the processor, the UTF-18. There will also be a part of optimizing, certainly at the end. What it does is already set up with the operator. In reality, it only activates the part of the terminal symbols where it receives what are constants. The same, it essentially manages this. It does nothing else. If we also look at the expression, it does this, but why did I wait a little? This implementation, because C is not the true language suitable for porting programs. Regarding the 6502, because essentially what pointers are, it does with the indirect comma, and here we have 5 or 6 cycles. If it directly passes what is beyond the page, then it is indeed costly. In contrast, other functional languages receive by value, return by value, and look here. Even with correct optimizations, we could return a value with 2 or even 3 and 0. Pages that, let's say, for these machines from 6 to 7 cycles to 2 or 3 cycles actually speeds it up. Then there's the execution. Well, what can I say? I thank you for staying with me up to this point. It has been a brief presentation of what it is. The high-level assembler for Commodore 64, 128, VIC-20, and the Commodore machines in the future, but also with the time that I can dedicate to this project. I will carry it forward and keep you updated. Thank you again to everyone for staying with me up to this point, and I wish you a good continuation. Claudio,